Good morning, class. So today, in previous video, we have completed that Rutherford atomic model, and I hope it is clear. I have to explain that why Rutherford has used gold atom and gold foil to observe that. Yes, so that was that model didn't work for a long time. There was some demerits in that. There was some limitation in that, and that limitation also we have discussed that Rutherford was not able to describe about the stability of the atom, as well as it was failed to explain the number of electrons and protons present in any atom. The electronic distribution also, he didn't explain that how the electrons will be arranged in that and how many electrons will be arranged. So to overcome all that defect of Rutherford, Bohr atomic model came in existence. Okay, so in this Bohr atomic model, what are the things important? Although this is also not 100% correct, this is also having some demerits, limitation, but for longer time it is it worked. Okay, so let's start with this. This model was proposed by Niels Bohr in 1913. Okay, according to this, this is the Bohr model proposed by Niels Bohr, and he said that this in the center is nucleus, and the electrons are moving in this fixed path. This is one path, another path, third path, and the fourth path. Okay, we can see the first, which was very closer to nucleus, were termed as K. After that, it was L. The first orbit, this is the first orbit, was named as K. The second orbit was termed as L. The third orbit or the third shell was termed as M. And the fourth orbit or the shell was termed as N. Okay, so shell or orbit both are same thing. Okay, so Niels Bohr said that whatever the postulates are there, I'm going to explain one by one. Let me start with this postulates of that. According to Niels Bohr, that atom consists of very small, heavy, positively charged nucleus in the center, and the electrons revolve around in the circular path that is called orbit. So if anybody asks that what is orbit or define orbit, what is that? The circular path around the nucleus in which electron revolves is called orbit. Yes, the circular path around the nucleus in which the electron revolves, that is called orbit. Yes, and they are named as K, L, M, N. For them, the values are 1, 2, 3, 4, and so on. So, yes. Second postulate is, in a particular atom, the orbit in which electrons revolve are the discrete orbit. This is discrete. Discrete, that means having a fixed radii and energy. Their energy are constant. It is not going to change. For each and every orbit, there is a fixed energy. Okay, so that's why it is called discrete orbit. And since their energy that doesn't change, so that's why it is also called stationary state. Okay, these discrete orbit are also called energy levels. These are numbered as 1, 2, 3, 4, and as we move outward from the nucleus, they are represented by letter K, L, M, N, etc. as shown. If we go in previous slide, this K shell, which is closer to the nucleus, is having lesser energy, and as we move away from the nucleus, the energy level keep on increasing. Got it? Now the third thing, this is the we can see that this is the nucleus and the first energy shell, the second energy shell, the third energy shell, and the fourth energy shell. The first one, which is closer to nucleus, is termed as K. For this, the orbit number is 1. Second energy shell is termed as L, and for this orbit number is 2. Third energy shell is named as M, and for this energy orbit number is 3. And similarly, fourth energy shell is termed as N, and for this the orbit number is 4. Okay, I hope it is clear. Now other postulates. The energy of these shells increases as we move outward from the nucleus, as already I have told you, thus representing the energies of first, second, third, fourth shell, etc. by E1, E2, E3, and E4. And as I told you that E4 will have the highest energy and E1 will have the lowest energy as it is closest to the nucleus, and this is farthest from the nucleus. Yes. As long as electron is revolving in a particular orbit, this is also very important point. As long as electron is revolving in a particular orbit, it can neither lose energy nor gain energy. जब तक वो किसी फिक्स्ड ऑर्बिट में मूव करता है तब तक वो तो ना तो वो एनर्जी को लूज करेगा ना ही एनर्जी गेन करेगा. एंड दिस postulates explains the stability of atom, because it is not moving, it is not releasing energy, it is not losing energy, so it will not collapse, in which that was not happening in the Rutherford. Yes, Rutherford didn't explain this thing, so that's why that in that case atom was unstable and it was collapsing. Yes, but in this case, since it is moving in a fixed orbit and their energy doesn't change, it neither lose nor gain the energy. That's why that atom doesn't collapse with the nucleus, and it shows the stability of atom. The state of atom which lowest energy is called ground state, while the state of atom with the highest energy is called excited state. Lowest state में जो होगा वो ground state कहलाएगा, and the highest one is called above the ground will be called excited state. Yes, the same picture I have explained that. Next postulate, energy is lost. ऐसा नहीं कि energy lost or gain होता ही नहीं है. That will also done. Yes, energy is lost or gained by an electron, but only when it jumps from one orbit to other. जब वो एक orbit से दूसरे orbit पे jump करता है, then only it will either lose energy or it will gain energy. ठीक है? And the energy gained or lost is equal to the difference of energy of the two energy level involved. Like this one, let me show this. This is the nucleus and this one is the E1 energy shell. This one is the E2 energy shell. In this, the electron is going from E1 energy to E2. That means here it is energy, it is absorbing. You can imagine, assume it like you have to move from ground floor to first floor or second floor. What you have to do? You need energy. You absorb energy. But when you have to come from fifth shell or fourth floor to ground level, very easily you come. Yes, you don't feel any energy is used. Yes, so in that case energy is emitted, energy is released. So when the electron jump from lower energy state to higher energy state, it absorb energy, and when the electron jump from higher energy to lower energy, it release the energy. Got it? I hope it is clear. So how much it will release, or how much energy it will release, or how much energy it will gain, that will be equal to final minus initial energy shell. Like in this case, the final one is E2. So the energy absorbed by electron will be what? Whatever the energy is there in the E2 shell minus E1 shell. Got it? In this case, the energy is emitted. So here the final one, हमेशा final minus initial करते हैं. Final one is E1. So we will say that E1 minus whatever the energy is in the E1 shell, first shell, minus E2's. Yes, I hope it is clear. Any doubt? The atom is then said to be in the excited state. If it jumps from lower energy state to higher energy state, it will be called excited state. And in the excited state, the atom is not stable. On the other hand, it loses or emits energy and jumps back to some energy, some inner energy level. Like if it goes to here, it is not like that यहाँ जाके वो stable हो जाएगा. What will happen? It will immediately lose the energy and will back to the ground level. Like if you throw the ball in the sky, so what happens? It goes up, but after reaching at a certain height, it comes back also. Yes, so at the excited state, the electron is not stable. So what it does do, it just lose or emits the energy and jumps back to the lower energy level. Got it? Now you can see that this one is jumping, so that's why higher से lower में आ रहा है, so energy releasing. Now lower to higher, so energy absorbing. I hope it is clear, this animation. Yes, Chaliye, let's move to next. Atomic number. This we have already done in class 9th, third chapter, and I hope everyone is clear with this. Atomic number is represented by Z, and it is like in 1913 Mosley introduced an atomic parameter called atomic number. Atomic number was given by Mosley in 1913 only. Atomic number of an element is equal to the number of protons present in the nucleus of an atom of that element, and that is denoted by Z. We have already done. Atomic number is represented by Z, and it is always equal to always equal to number of protons present in any element. Yes. Next, atomic number. Atomic number is denoted by Z, and it is equal to number of protons the same way as I have told you. For the neutral atom, if we talk about the neutral atom, Z will always be equal to proton. Okay, Z is not going to change. चाहे वो neutral हो ना हो, it will be always equal to proton. But if the atom is neutral, that means it is not having any charge. Then in that case, proton or electron will be same. And since proton is already equal to Z, so क्या हो जाएगा? Z will be equal to proton will be equal to electron, and that formula also we have done in chapter 3. I hope it is clear with you. Okay. Now, if the cation is there, cation that means which is having positive charge. If for the cation A is having positive charge, so in this case the electron cation कब बनता? When it loses the electron. Got it? If it loses the electron, that means previous से electron अभी क्या होगा? कम होगा. Clear? So in this case, electron is always less than proton. I hope it is clear. Yes. If it is cation, that means it has lost the electron. If it will lose the electron, obviously the final electron will be lesser than the initial one, isn't it? So in this case, electron will be less than proton. So in that case also, Z will be equal to proton, but proton will not be equal to electron. I hope it is clear. So how you will find? Electron को find करने के लिए क्या करेंगे? जो previous था, that means proton के बराबर था, yes, minus whatever the charge is here, like x. This is. So जितने electron इसने lose किए, उतने को हम minus कर देंगे. We will get the electron. Is it clear? Let me repeat it again. Atomic number is always equal to proton. It is not going to change whether it is cation, neutral, anion, whatever. So Z will be equal to proton. If it is cation, cation will be formed by losing the electron. Yes, so if it is losing the electron, the final electron will always be lesser than the initial one. Yes, initial one was equal to proton. Yes. So how we will find the final electron? Electron will be equal to proton minus whatever electron here, x. This x represents that how many electrons it has lost. Yes. So just subtract this, you will get the number of electron currently present with that atom. Yes. We'll do with the example. First, let me explain this anion. If it is anion, that means it has gained electron. It has gained electron. So in this case, the electron will always be greater than proton. पहले जितना था उससे ज़्यादा उसने उसमें 1, 2, 3 whatever इसने gain कर लिया. तो जो पहले था उससे अब ज़्यादा हो गया, isn't it? In this case also Z will be equal to proton, as I told you. Everywhere Z will be equal to proton. See, this is anion. Z is equal to proton. This is cation. Z is equal to proton. This is neutral. Z is equal to proton. Yes, always equal. But yes, in the cation or anion way, this electron won't be equal to proton. Okay? So how you will find the electron? Now this is electron. Proton to pehle tha hi jitna. Now it has gained someone. So whatever it has gained, that we will add and we'll get the number of electron. Yes. So this charge is, that means only x. X is the charge. This x is called charge. Okay. I hope it is clear. Here this minus and positive, this explains that if it is positive, that means it is cation, and if it is minus over here, that means it is anion. Yes? Any problem? Let's do some example. Before that, this is the mass number. New topic, mass number. It is denoted by A. Yes? And it is also called nucleons, and it is always equal to sum of number of neutrons and protons. A मास नंबर को डिनोट करता है. दिस इज ऑल्सो कॉल्ड न्यूक्लियॉन्स. और न्यूक्लियॉन्स जो होता है दैट इज ऑलवेज द सम ऑफ नंबर ऑफ न्यूट्रॉन्स एंड प्रोटॉन्स, वेदर इट इज cation, न्यूट्रल और anion. The A is also not going to change. If it is cation or anion, what only is going to be affected? Only the number of electron. Rest all thing will be same. Yes. So there is a formula for A. Let me write here only. A is equal to this mathematical, ये जो मैंने language में लिखा हुआ है, we can do it in the mathematical way. A is equal to n plus p. Yes, I hope it is clear. So we will use this formula also. Now representation of atomic number and mass number with the symbol of an element. कैसे represent करते हैं? Mass number will always be written as a superscript. Always be superscript. ठीक है? Be very very careful about this. If A you will write as a subscript, it will become completely wrong. And Z, atomic number, is always as a subscript. Okay, so this is the symbol of element. This X is an element, whatever the element, and A we will write as a superscript. It doesn't matter whether you are writing in the left side or right side. Okay, but it should always be superscript. Similarly, Z will be always as a subscript. It doesn't matter whether you are writing on the left or on the right side. Okay. Atomic number Z is written on the lower left side, where left side or right side we can write, there is no problem. Okay. Whereas mass number A is written on the upper left side of the symbol. Left side or right side, that is not important. The important one is upper and this is lower. Okay. For example, carbon has atomic number, that means Z is equal to 6 and mass number 12. So how we will write that? Carbon, and this is 12, mass number is there, so we will write as a superscript, and 6 is atomic number, so we will write as a subscript. I hope it is clear. Now few questions. Calculate the number of electrons, protons and neutrons in sodium atom given that atomic number of sodium is 11 and mass number is 23. Already we have done such type of question in chapter 3. Just a recapitulation over here. Atomic number, that means Z. Z is equal to 11. Okay. And mass number, yani A, is equal to 23. So atomic number Z is equal to 11, A is equal to 23. You have to find electrons, protons and neutrons. So we know that Z is always equal to proton. So proton हमें मिल गया कितना? Will be 11. Number of proton will be equal to number of atomic number will be 11. And since it is not saying that it is a sodium atom, it is not sodium cation or sodium anion. So what we will do? Z electron will also be same, and hence number of electron is also same as 11. Yes. So we found that Z was 11. It was mentioned in the question only. Now proton, we got it. That proton is equal to 11. And since it is a neutral atom, so electron is also same. That means 11. Now what next you have to find? You have to find the neutrons. Yes. So we have the formula that A is equal to N plus P. Isn't it? P plus N or N plus P. So P you know that, A you know that, number of neutrons can't you find? A minus Z, that means 23 minus 11, 12. So here we got this neutron will be 12. Yes. So simple question. Now another question. The nucleus of an atom of an element contains 17 protons and 18 neutrons. So protons you have, okay, neutrons you have. So by protons and neutrons you can find the mass number. Yes. So atomic number आपको find करना है और mass number find करना है, and then symbol you have to decide. So mass number, atomic number will be equal to proton. So that means atomic number is going to be 17 and mass number is equal to N plus P. So 18 plus 17, that is 35. So 17 atomic number 17. So it is representing chlorine. So we will represent like this. Yes. Atomic number is Z, that is always equal to number of protons. Proton is given 17. So it will be equal. Mass number is equal to proton plus number of neutrons. That means 17 plus 18, 35. Since atomic number is 17, so we'll say that this is chlorine, and that is the answer. Yes. Another question. The symbol of oxygen atom is O816. What is the name given to the number of protons in the nucleus of the atom? What is the name given to the number of protons in the nucleus of the atom? So you have to say कि what name it is given over there. So 8 atomic number अगर है, that is a nucleus में क्या दिया गया? So nucleus में क्या होता है? We know that it is always neutron and proton. So out of neutron and proton, which one is equal to atomic number? We'll say yes. So number of protons, it is same. It is same. अब यहाँ proton लिखा हुआ है. So what is the name given? Other name? Atomic number, isn't it? So that is the name given a atomic number, and it is always equal to proton. So that will be 8 over here. Next, what is the name given to the number of protons plus number of neutrons? What is the name given? Nucleons, isn't it? Here it is asking neutrons, a number of neutrons plus number of protons. That is called nucleons, isn't it? Or nucleons is also known as mass number. So mass number is equal to neutron plus proton, and that is given here 16. Yes, I hope it is clear. 16 is the mass number, or you can say that the nucleons. So in that case, neutron can you find? Yes, easily you can find, because atomic mass you know that, matlab mass number you know that, and atomic number you know that. So this upper minus lower karoge, you will get the number of neutrons. I hope it is clear. Any doubt in this? Now our next topic is electronic configuration. How we have to divide the electrons in their orbit, in the orbits, in the shell. That we will do in our next class. So I hope whatever I have explained today, that is clear to you. If there is any doubt, feel free to ask. Okay. Watch the video properly, make short notes, and enjoy your study. Thank you, class.